Welcome. I'm starting a series of videos called Understanding Space Weather. Space weather is the study of how changes on the Sun can affect the entire solar system. In the case of the Earth, it can degrade or even destroy our modern technologies and thus affect our daily lives. The first video in this series is called The Sun as a Variable Star. Space weather has become a new theme of the American Meteorological Society. So I'm writing a series of 5 papers in the Bulletins of the American Meteorological Society, which is their flagship scientific journal, on space weather. The first one was called The Sun as a Variable Star. The second one is called The Violent Sun. The third one, The Sun's Domain. The fourth one, The Sun-Earth Connection. And the fifth one, Effects on Life and Society. The first one has already been published and is available online. The other two have been accepted for publication and should be published very shortly. As I said, the first paper is already available online. I wrote this paper in conjunction with two of my colleagues, Dr. Julia Saber and Dr. Terry Kuchera. And if you want to see the paper, you can go to the URL that's listed at the bottom of this page, or simply go to Google and Google BAMS Keith Strong and you'll get to that particular paper. Not many people know that the Sun is a star. In fact, it's quite an ordinary star. About 1 in 10 of the stars in this picture are Sun-like stars. That would make about 20 billion Sun-like stars in our galaxy. Now, most of those would have a planetary system, and about 1 in 5 of those planetary systems would have an Earth-like planet. So there's probably about 4 billion Earth-like planets in our galaxy. How many of those would have life? That's a very interesting thing to contemplate, however it's not the subject of this video. The Sun changes. We see generally a constant sun in the sky, and that's reassuring because it provides us with the heat and light we need for life on Earth, for all living things on Earth to survive. We use the Sun to define the length of the day and the length of the year. We see the seasons change as the Sun's height in the sky changes, in the winter being low in the sky, in the summer high overhead. But when the Sun disappears, as it did on the 21st of August of this year during a total solar eclipse, it can be quite worrying, it can be quite stunning, particularly when you don't understand what actually is happening. But if we could look at the Sun at different wavelengths or in different ways than we do from just using a naked eye, we see that the Sun changes in many other ways, and those ways are quite interesting and quite important. Changes on the Sun can be rapid, somewhat slower, or very long term. Let's take a look at some examples of rapid changes on the Sun. One of the best known ones is flares. These are massive explosions of radiation on the Sun that stream out in all directions into space. There are also coronal mass ejections which spew tons of material out into space, and in fact you notice that this particular explosion is larger than the Sun as it expands out into interplanetary space. And then there are solar wind gusts. The solar wind is the outflow of particles from the Sun, but the rate at which it flows can change by factors of 4 in very, very short time scales indeed, reaching up to say 800 kilometers per second. There are more leisurely changes in the Sun, but nonetheless just as important. For example, the Sun rotates. It rotates once every 28 days at the equator, a bit slower at the poles, and that's a very important observation, as we'll see later. This was first discovered by Galileo, who tracked some sunspots crossing the Sun. Sunspots themselves are a feature that can appear relatively quickly in a few hours, but they can remain around for several rotations of the Sun. Coronal holes are open areas of solar magnetic field through which the high-speed solar wind has an avenue to escape. But once they form, they can remain around for a long time. This particular coronal hole was around last year and lasted for 9 months before it dissipated. Filaments and prominences are one and the same thing. Filaments are these dark channels on the disk, but when they get near the limb they show some height structure. You can see some of them around the limb here on the right. They are cool material, cool dense material suspended in the solar atmosphere, and they can last for a very long time. They can equally disappear relatively quickly, but then often reform. Here are some examples of long-term changes on the Sun. One of the best known is the 11-year sunspot cycle, where at solar minimum there are hardly any sunspots on the Sun, and at solar maximum there are large numbers, up to 200 or so. Less commonly known is that there's a 22-year magnetic cycle, and this reflects the fact that the sunspot polarities reverse every cycle. So what was positive in one cycle becomes negative in the next cycle, and vice versa. You can have grand solar maxima and grand solar minima. The prime example of that is the Maunder minimum, and the number of sunspots observed during the Maunder minimum was very, very small indeed. Although there weren't that many observations, so we have to be a little careful here. But nonetheless, there is indications that this was a long period, like 70 years, without many sunspots. And the Sun goes into those sorts of periods on average about every 400 years, it seems. But however, that period is not constant. It's something like they've been separated by as short as 50 years or as long as 1,000 years. So it's not a regular beat phenomenon. And then the very long-term effect is solar evolution. For the last billion years, it's grown about 30% in intensity and will continue to get hotter as time goes by. The Earth will probably become uninhabitable for most life forms by about 1 billion years time. So we better get our skates on and get off this planet. In about 7 billion years time, we will form a red giant, which will certainly encompass the orbit of Venus and may even encompass the orbit of Earth. Eventually it will form a planetary nebula and a white dwarf, which will go on for billions of years more. I hope that has given you some idea of how the Sun changes. In our next video we're going to talk about how much energy the Sun produces, where does that energy come from, and how difficult it is for that energy to escape from the Sun, and how those processes cause the changes on the Sun that we see. So until next time, stay safe.